Hi all, in this video I am going to explain how to find the voltage Vx across 10 ohm resistor. Consider the circuit. The circuit consists of independent voltage source and dependent current source. Independent voltage sources are 12 volt and 24 volt and dependent current sources 10 Ix because it depends upon the current Ix. The question is, find the voltage Vx across 10 ohm resistor. To find the voltage Vx across 10 ohm resistor, we should know what is the current flowing through 10 ohm resistor. To calculate the current flowing through 10 ohm resistor, I am going to apply the mesh analysis. What are the steps needed to solve the problem using mesh analysis? What is the step number 1? Mark the direction of currents for all loops. Second, all the currents are assumed to be clockwise direction. Okay, see this problem. How many meshes are there? There are 4 meshes or 4 loops. Here this is the loop number 1, loop number 2, loop number 3 and loop number 4. The current flowing to the loop number 1 is I1, loop number 2 is I2, loop number 3 I3, loop number 4 is I4. First of all, I am going to consider the loop number 1. All the currents are assumed to be clockwise direction. How to find the voltage equation for loop number 1? See the 4 ohm resistor. Okay, the current flowing through the 4 ohm resistor is I1. So 4 into I1. Next consider 12 ohm resistor. A 12 ohm resistor that shares the current I1 and I4. But to write the equation for loop number 1, we have to write with respect to loop number 1. So with respect to the current I1, I am going to write the equation. So 12 into I1 minus I4. Then plus, what is the next resistance? 8. 8 into 8 ohm shares the current I1 and I2. So 8 into I1 minus I2. And see the voltage. The current is flowing from negative to positive terminal, voltage rise. So that is equal to 24. Here also negative to positive terminal. So here voltage rise. 24 plus 12, that is 36. I am going to reduce this 4I1 plus 12I1 plus 8I1, that is 24I1. And next minus 8I2. Next minus 12I4 equal to 36. This is the equation number 1. Here all the numbers are divided by 4. So equation 1 is divided by 4. I get 6 into I1 minus 2 into I2 minus 3 into I4 equal to 9. This is the equation number 2. Then consider the loop number 2. Here in a loop number 2, how many resistances are there? 1, 2 and 3. 3 resistances are there. So first consider 8 ohm. 8 ohm resistance shares the current I2 and I1. But with respect to the current I2, I am going to write the equation. So 8 into I2 minus I1. Then 15 into 15 ohm resistance shares the currents I4 and I2. But with respect to I2, I am going to write the equation. So 15 into I2 minus I4. Plus consider the resistance 6. So plus 6 into I2 minus I3. That is equal to, see the voltage source, the current is flowing from positive terminal to negative terminal, voltage drop. That is equal to minus 24. Have to reduce the equation. Minus 8 into I1 plus 15 plus 8 plus 6. That is 29 I2 minus 6 I3 minus 15 I4 equal to minus 24. This is the equation number 3. And next consider the loop number 3. Here I am going to apply the mesh analysis. We are having only two resistances, resistance 6 ohm that shares the current I2 and I3, but with respect to I3 I am going to write the equation. So 6 into I3 minus I2 plus in a 10 ohm I3 current is flowing 10 into I3, that is equal to 0. So minus 6 I2 plus 16 I3 equal to 0. The equation is divided by 2, that gives minus 3I2 plus 8I3 equal to 0. This is the equation 5. Then see this loop. In this loop consists of current source. So this is coming under super mesh. How to write the equation? I4 equal to 10 into Ix. Both the currents are in the same direction. How we can write Ix? Ix equal to, see, Ix equal to, I2 and Ix both are same direction. So Ix equal to I2 minus I3. So 10 into I2 minus I3. Have to expand this. 10 into I2 minus 10 into I3 minus I4 equal to 0. This is the equation 6. So totally we are having 4 equations. Equation 1, equation 2, equation 3 and equation 4. Now I am going to arrange these 4 equations. 6I1 minus 2I2 minus 3I4 is equal to 9. Minus 8I1 plus 29I2 minus 6I3 minus 15I4 equal to minus 24. Minus 3I2 plus 8I3 equal to 0. 10I2 minus 10I3 minus I4 equal to 0. I am going to write in the matrix form. So 6 minus 2, there is no I3 here, put 0, minus 3. Then minus 8, 29, minus 6, minus 15. 0, there is no I1, minus 3, 8, there is no I4, 0. Then there is no I1, 0, 10, minus 10, minus 1. Put the 4 currents I1, I2, I3 and I4. Here put the values of voltages 9, minus 24, 0, 0. Next I am going to solve the currents one by one. Here this is the 4 cross 4 matrix. So I have to use the MATLAB to solve this. So delta equal to 6. First of all I have to write the matrix. This is delta. So find out the determinant for this matrix. And next I am going to find out delta 1. So how to find out this? Here for the second row, first row, it is replaced by 9 minus 24, 0, 0. And remaining there is no change to find out delta 1. And how to find out delta 2? The second row is replaced by 9 minus 24, 0, 0 and find out the value determinant, that is delta 2. How to find out delta 3? The third row elements are replaced by 9 minus 24 and 0 and find out the determinant, this is delta 3. And how to find out delta 4? The fourth column element, not row. Fourth column elements are replaced by 9 minus 24, 0 and find out the value, that is delta 4. And how to find out I1, I2, I3 and I4? I1 equal to delta 1 by delta. I2 equal to delta 2 by delta. I3 is delta 3 by delta and I4 is delta 4 by delta. So these are the values. Okay, these are the values for delta 1, then delta 2. Here this is delta 3. Then this is delta 3 and this is delta 4. Not delta 3. This is delta 4. Next I am going to explain how to find out the determinant delta 4 using matrix method. Have to open the MATLAB window. Here I am going to substitute the value. So 6 minus 2, 0, 9, minus 8, 29, minus 6 and minus 24, 0 and minus 3, 8 and 0, 0, 10, minus 10 and 0. Okay. Then you have to put D is equal to, what is the command used to find out determinant of the matrix A. So this is the value, that is 3600. The value is 3600. Have to put the value here. Okay. And next I am going to find out this I2 and this is I3 and last I4. Okay. How to find out this? This is del 3 divided by delta. And this is del 4 divided by delta. Okay, now the value, no. That is, delta is 4 by 4, 4. 3600 divided by 4, 5, 4, 4. What is the answer? 0.7923. 0.7923 is the answer. Okay, these are the values obtained. In this way, you have to apply the MATLAB to find out the determinant. After finishing this, I am going to find out the value, that is voltage across 10 ohm resistor. So how to find out the voltage across 10 ohm resistor? The current flowing through 10 ohm resistor is I3. So what is the current flowing? 0.475. The current flowing through 10 ohm resistor. And what is the resistance value? 10. What is the voltage across 10 ohm? That is 4.75 volt. This is the voltage across 10 ohm resistor. Okay, in this way, we can easily find out the value for the dependent current source using mesh analysis. Okay, next I am going to explain how to find out the voltage across the 10 ohm resistor using Next I am going to explain how to find the voltage across 10 ohm resistor using MULTISIM simulation software. See here how to connect this: first 12 ohm, then 4 ohm, 24 8 ohm, then 12 ohm, 15 ohm, then 10 ohm. Here this is the dependent current source. Okay. Then this dependent current source, one of the terminal is connected to 6 ohm. The next terminal is connected to next end of the 6 ohm. Okay, this is connected to next end, and this is connected to the ground terminal. Okay, in this way you have to connect the dependent current source. Okay, this end is connected to the ground, and this is connected to the 6 ohm resistor. In this way, you have to connect this dependent current source. And then you have to click on this run button. Okay. Then stop this. Afterwards, I have to connect the probe here because I am going to find out the voltage across 10 ohm resistor. No. So what I have to do, I am going to connect the probe. Okay. So what is the voltage obtained? 475 millivolt, or what is the answer obtained already? That is the 475 millivolt or 0.475 or 0.5 volt. Okay, this is 0.0475. So, wrong. 0.475 volts. Okay. The same answer obtained here, 475 millivolt or 0.475 volt. That's all. This is the way to find out the voltage across 10 ohm resistor using MULTISIM simulation software. Thank you. Have a nice day.